Okay, pre-calculus, we're going to learn about modeling with functions. You can see the sample problem. So we want to model word problems with functions, be able to solve some difficult pieces. So a farmer is making a pen out of 600 yards of fence. He'll be dividing the pen into 3 sections that are all equal in size. What dimensions should he make the pen to maximize the area? I like to organize my thoughts when I do these problems, and I remember VFFG. And that's for visualize, formula, function, and graph. So this is what I do. I do it all the time. Make it 4 squares. Those 4 pieces we fill in, and we get our solution. Simple as that. Visualize the problem. Farmer is making a pen out of 600 yards of fence. So that's what I need to do first. Visualize it. If he's making a pen out of 600 yards of fence, pen looks like this. He's dividing the pen into 3 sections. So 1, 2, 3. They're all the same size. It's not the same size, sorry, but it's okay. And what dimension should he make it? Well, dimensions are, in this case, width and length. You can see that I have width, 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 and width. I have 2 lengths. Okay? Well, formula. What kind of formulas do we need to solve this problem? We have a couple. First one we need is area. We know that area is equal to length times width. But also I have a total of 600 yards of fence. So that means that perimeter will be the sum of all the pieces. I have 4 widths. I have 2 lengths. I know that the perimeter is equal to 600. What I need to do is I need to combine my formulas for area and perimeter in order to write one equation. So I'm going to solve for L. Subtract my 4W. I'll have 2L is equal to 600 minus 4W. Divide by 2. L is equal to 300 minus 2W. So I can put that in for there, and I will have an equation for L. So now I write a function, and a function is descriptive. It's an area function, and it's in terms of my width. That's your variable. So let's write a function. We have area in terms of width is equal to W times 300 minus 2W. If I distribute that through, I have area in terms of W is equal to 300W minus 2W squared, or negative 2W squared plus 300W. I've written my function. Now it's time to graph it. If you graph that, it looks like a parabola. It's like a parabola that's upside down. We know that because you have negative 2W squared, so 2W squared means it's a parabola, negative means it's upside down. And if we're trying to maximize the area, again, my variable is W, so this is W for width, so the width axis, and area is my Y value. So, how do I graph a parabola? I need to be able to find the vertex. So I take negative b, or negative 300, divided by 2a. 2 times negative 2 is negative 4. That equals 75. So that's, for width and area as your coordinate, 75 is your width. If you want to find the area, plug it back in. We don't have to find the area. It says what are the dimensions that I should make it. So I know that the location of the vertex, the location of the max, the location of the vertex that the x value is 75. If I plugged it back in, I would get the actual area, but I just need the length because it says find. Well, if I look back up to, this right here, I know that length is equal to 300 minus 2 times 75. So length is equal to 300 minus 150, so length is equal to 150. So 75 by 150, the width and the length. There you have it. So my 4 boxes, BFFG, visualize, formula, function, graph. That's what we do. Let's try another one. Farmer builds a fence against a barn, thus he does not need any fencing against the barn. If he has 320 feet of fencing, what dimension should he make the fence to maximize the area? Same deal as before. Make my line super straight to impress you guys. Like this. And B, F, F, G. Visualize. It's got a fence against a barn. It's my barn, there's my fence. It needs 320 feet of fencing. So he's got width, and length. Maximize the area. I want to maximize the area. Again, formula. I got area is equal to length times width. What else do I have? Well, I have perimeter is equal to 2 lengths plus 1 width. I'm sorry, 2 widths plus 1 length. Okay. So the perimeter is equal to 320, so 320 equal to 2W plus L. Subtract 2W from both sides. L is equal to 320 minus 2W. So I can take that, plug it in for L. My function expresses a variable, in this case area, in terms of W. Area in terms of W. W times 320 minus 2W. Distribute through negative 2W squared plus 320W. What shape is that? Well, the shape is a parabola that's upside down. Looking for the maximum area. That's the area axis, that's the width axis. That's the max, it happens at the vertex. We want to figure out where that happens. In order to figure it out, I do negative b divided by 2a. Negative b divided by 2a. So negative 320 divided by 2 times negative 2, negative 4. 80. So 80 is that location. So if you had an a coordinate and a width coordinate, 80, width and a. It's the other way around. Width and area. Width is 80. Area, we don't care about. It says find the dimensions. Okay? So 80 is my width. In order to find the length, I can take my 80, plug it in right there. 320 minus 160. It's 160. Done and done. One more. A box with an open top is constructed to form a rectangular piece of cardboard. Dimensions 10 by 18 by cutting a square from each corner, folding the sides up. Find the largest volume the box can have. So, make a nice drawing here. Visualize. Formula. Function. Graph. Got a box. 18 by 10. We're going to cut pieces off of it. Formula. I'm concerned about volume. Well, volume is equal to length times width times height. As you can see here, the length is originally 18, but I only want this much of it. And I'm cutting off 2 x's. So 18 minus 2x. Similarly here, 10, I want to cut off some portions of it. So I have 10 minus 2x. As far as the height's concerned, when I fold the box up, it's going to have a height of x, so I fold it up. So therefore, the volume is equal to 18 minus 2x times 10 minus 2x times x. So we plugged everything in. Let's write a function for it. Function is volume in terms of x. That's equal to, we need to distribute our pieces through. Negative 2x times negative 2x, 4x squared. Negative 2x times 10, negative 20x. Negative 2x times 18, negative 36x. 18 times 10 plus 180 times x. So if we write that out, my volume in terms of x is going to be 4x to the third minus 56x squared plus 180x. So I distributed my x through. That's my volume formula. Now, you say to yourself, well, what does that graph look like? Well, we've talked about cubics. We know approximately what they look like. We don't know. We can't find a vertex of it. We'll figure out how to do stuff like that next year in calculus. Right now, I know that I have that kind of shape. And we talked about local mins and local maxes earlier in this course. That's a local max. That's the point we would like to find. So what I'm going to do is take out my calculator. And already did this, so let's clear this out. Zoom in a normal viewing window, that way we have everything back to normal. So y equals, I'll type in my function, which is 4x cubed minus 56x squared plus 180x and now I want to be able to graph that. Now just think about the viewing window for a second. X is obviously our variable of choice here, and that represents really what I'm cutting off. So if we go back to our original problem up here, this area that I circled, if you cut off those x's, the biggest x that we could cut off there would be 5, because if you cut 5 off from each side, you would have nothing left for a width. So 5 is the biggest you could cut off there. Whereas for that side, the biggest you could cut off is 9. So, that's, let's say, if 5 is the biggest that you cut off, then all you have to do is just set your window to include 5. So the fact that we go to negative 10 to positive 10, that's plenty to be able to make sure that we have 5 to be able to view. Now, as far as the range, how high does this thing go? Well, I don't really know. I mean, let's say we had a 10 by 10 by 10 box. Now, that's not possible in this situation. Let's say we had 10 by 10 by 10. Then my Y maximum value will go all the way up to, say, 1,000. So let's see if we can see it if we do that. If we hit graph, you can see that I can see the maximum there. I obviously went way too high. So let's change our window. I'm going to change it so I have a Y max of 300. And I'm going to go Y minimum negative 100. That way I at least see below the x-axis. I press graph here. Okay, there's a good shape. And what we want to find is that maximum. You can see as you compare it to the graph I've got right over here, and we're looking for that maximum spot. And the way that we find a maximum on our calculator, we can use our calculator to help us. We go on a second calculate into this section that we've gone into before, and we select our maximum, which is number 4. And it asks us to move to the left. Well, first I'm going to go up to my maximum spot. Okay, so it's right about there. And it says left bound, so I'm going to move to the left. Press enter. Now move to the right. Press enter. And I'm not going to guess. And I get 2.06. So what does that represent? Well, this coordinate right here, 2.06, is the x value. And the y value, I think we saw, was 168.1, something like that. So that's that coordinate. Well, if you think, this is an x value, and this is my volume in terms of x. So I guess I'm cutting off a square that's 2.06 by 2.06. But to answer the question says, find the largest maximum volume, or the largest volume that the box can have. So I guess we've answered that. The largest volume is 168.1. So there you have it. Once again, V, visualize. Draw the problem out. F, formula. What formula do you need in order to write your function? After you write the function, graph it. You'll come up with your solution. There you go. Good luck. Hope you guys do very well.